Welcome back. Yes, we are back. Whoa, get it. I don't know. But yeah, here we are on a Friday. Oh, happy day. I'm going to stall a little bit to allow people to kind of get in right now. And then I'll explain exactly how today's class is going to run and what I am planning for next week. If you would, as I already see one comment, with the rest of you, please leave a comment in the chat for my records. That'd be fantastic if you would. Hopefully as people are coming in, they're also realizing that they should leave a comment in the chat. That'd be fantastic. Everyone kind of, flying through. Joe's left 2 comments now. I don't know. It's weird, but it is what it is. Hope you all enjoyed your, I'm going to put this in quotes. I hope you all enjoyed your snow day. Weird. Yeah, I wonder, have we seen the end of snow days in Barnegat? I wonder. Like, are we never in Barnegat ever going to have a snow day ever again? Have you just experienced the last snow day like last year? Did we even have a snow day last year? I don't even know. I can't even remember because I had to teach from my bedroom desk yesterday. Weird. Anyway, so how is today going to run? Today, I have planned some practice problems for solving radical equations. And I have a plan for how I'm going to handle that for people who feel like they need a little extra practice and for people who feel like, no, I can handle this, let me go. Not that I'll let you go, but let you go in terms of solving problems. You'll see. It's going to be interesting. That's the main thing that I have planned for today. Now, in terms of next week, I do have planned two specific assessments. Number one, I would like to at some point get in a minor assessment in regards to this whole solving of radical equations. But again, that's for next week. Today is meant for practice. Next week is meant for that assessment. And I am also building towards a major assessment that I would like to take that would encompass most of Chapter 6, which we've been covering since like the beginning of January. Part of Chapter 6 was on that midterm. I want to revisit some of that information, of course, in preparation for this major assessment. Next week, I have you on Wednesday and Friday. I have you on Wednesday and Friday because Monday you have no school. Friday is when I'm aiming for that major to be taken, and it will be pretty much taken on your own accord. I'm going to have like an online assessment for you guys to take care of, as we typically do. Yeah, I'm going to have to knock out those couple of assessments next week. But today is for practice. Today is meant for practice. I see all of your wonderful comments right there. Thank you for those. And here we are today. I don't even know. It's sad. As a side note, I grew up in Barnegat, and obviously, most of you know the best sledding location is Dumpy Hill. Now, what's interesting about Dumpy Hill is the way that it has evolved over time, because today, when you guys think Dumpy Hill, you think of, when you're looking at the school, it's the hill to the left. That's what most people kind of think when they think Dumpy Hill. But when I was a kid, Dumpy Hill was actually way off to the right, where I think that's Bayshore Drive right there. Today, there's a parking lot. There was no parking lot when I was a kid. It was a straight shot all the way down, and that thing was steep. Man. More often than not, if you got like good just a good start and a good slide, you could end up from the top of the hill all the way in the street. It's pretty awesome. Oh, good times, good times. Anyway, in terms of what I promised in terms of practice for today, I would ask that this information be put in a specific location. So if you do not already have them out, I'm gonna need those notebooks out and open. Yes, let's do it. Woo! Friday. Okay. So, what I have done is this. In your Google Classroom, obviously you found the link for today there, but in your Google Classroom for period 3A, from the other day, I posted this PDF. This PDF, which asks for you to solve the equation and check for extraneous solutions. You have this PDF. Now, in a few moments, I'm going to give you 2 sets of problems. And I'm just going to give you the problem number, and those numbers are going to be based on this worksheet. And what's going to happen is this. The first set of numbers, I am going to slowly but surely work my way through those problems, giving suggestions and verbal cues in terms of how to solve those particular problems. If you feel like you need my guidance and my help with solving these radical equations, which we just started a few class periods ago, but if you feel like, I am not too confident, I kind of need your help on this, please walk me through it, then you will pay attention to me as I go through those problems. But if you feel like, you know what, I got this, I know what to do with these problems, I know how to solve these problems, then you can work on the second set of problems. And I'm going to leave you to do those. And then once I'm done with the first set, then I can review a few of the problems from the second set just to confirm, hey, did you get them right? Did you do the right thing, et cetera, et cetera. So in a moment, I'm going to give you 2 sets of problems. The first set, if you feel, and you know yourself better than anybody, but if you feel like, I need your guidance, I need you to walk me through this, then you will pay attention to me as I go through that first set of problems. But if you feel confident, if you feel like I got this, if you feel you can handle these problems, then you can begin working on the second set of problems. All the problems are coming off of this worksheet in your Google Stream. So you have the problems right in front of you. I'm going to ask that you stay on the live stream, that you stay on the video, because obviously once I'm done going over the first set of problems, you can then ask me questions and I can go over various stages of the other problems with the time that we have left. So, set of problems number 1. Let me just kind of change this over so I can show you exactly. And I'm going to suggest that you write these down. Simply because they're not going to be on the board the entire time. What is that? Can I erase that? Yeah, I can erase that. Okay, back to this. The problems that I'm going to have you working on, and keep in mind the entire time, regardless of which one you end up doing, I am going to have the live stream going on my phone so that I can answer any questions if you have them along the way. But with me versus on your own. So I'm going to suggest that you do write down both sets. Perhaps at one point you're working with me and you feel like, you know what, I think I could do these. And then you can work on some of those problems on your own. But here are the problems you're going to do with me. 2, 6, 11, 16, 21, 22. those are the problems that I'm going to begin going through in a little bit after I kind of set you off on your paths. If you're going to be working on your own, if you're going to be trying these problems saying, I think I can do them, then I want you doing 4, 7, 12, 15, 20, and 25. There we go. So like I said, I do have the live stream open up in front of me. So if you do have any questions, if you're working on your own, you can ask them directly in the live stream and I can clarify. Now, keep in mind, I'm not going to clarify correct answers just yet because obviously I'm going to go over various ones later. But if you have a question in terms of like, hey, do I do this part for this? You know, like that kind of, like any kind of clarification, that would be fantastic. So you have your task. You know yourself better than anybody else. Joe, good question. I had posted in, what day did I post it? I posted on February 9th. I posted it on February 9th in our Google stream. Just a reminder, on Tuesday, Fridays, I am scheduled for office hours from 12:30 to the end of my workday. If you desire extra help or have questions of any kind, please email me to schedule. Obviously, we can go beyond the 10-minute window. So that's my answer to after school meets. I posted that reminder. When did I post that? I posted that 3 days ago. 3 days ago. So I did that mainly because I posted it to everybody as a reminder because of the new semester and because I have brand new classes, electives that I'm teaching. So anyway, so you know yourself better than anybody. If you feel confident, start working on these 6 problems from that worksheet in the Google stream. If you feel like you need clarification, if you need help, if you want my guidance with these, I'm going to begin working through these. All right, let's do this. All right. Come on, microphone. There we go. Okay. So, first problem, let's take a look at if you're working with me. Let me get a new marker out of here. I don't want this one. Go away, old marker. Nailed it. So, in terms of my notes, today is the 12th. And this is solving radicals practice. And I'm working on a number 2. Let me write down number 2. That would be helpful. There we go. So here's number 2 off of that practice worksheet. Again, the goal is to solve, get X by itself, and then check for extraneous solutions. How do you check for extraneous solutions? Well, you plug your solution back into the original to see if it works. Typically, you will have an extraneous solution if you end up with something like 1 equals -1 or 5 equals -5 or some junk like that. If you end up with something like 10 equals 7, then clearly something went wrong. But that remains to be seen. I remind you of SADMEP. SADMEP is the order in which we are going to peel off these layers. I want to deal with any outside addition, subtraction first, any outside multiplication, division next, exponents third, and leave parentheses for last. There are no parentheses on this problem. So thankfully, we don't have to worry about that. So let's game plan. The 7's being added. Typically, I'll probably have to deal with that first. The 2 is being multiplied. And the 3/4, that's the exponent that's being raised to. I'm going to peel off the layers in the order of SADMEP. I got to peel off the 7 first by subtraction. Once I peel off that 7 by subtraction, I get this whole thing equal to 16. Then I'm going to divide by 2. According to SADMEP, multiplication division is next. I'm going to divide by 2. And I get x, well, not by itself just yet, but now I have it equal to 8. Finally, I'm going to deal with that 3/4 power. Now, dealing with that 3/4 power, I'm going to raise both sides to the power of the reciprocal. If I raise both sides to the 4/3 power, move that down a little, 4/3 power, that will cancel out. I'll move this up a bit. There we go. That will cancel out the exponent on the left, like so, leaving me with x equals whatever 8⁴ is, which I'll deal with in a moment. First, before I write that, let's check a few things. Did I introduce a radical or a root to the problem? Yes, I did. I introduced a radical or a root to the problem. What type of radical or root did I introduce? This exponent is 4/3. That's what I introduced. Power over root. That 3 is the root. It is an odd root. See, the reason why I'm having this entire conversation is because of the need or no need of having a plus or minus. Do you need a plus or minus? In this problem, you don't. You do not need to introduce a plus or minus because, yes, you introduced a root. However, you only need a plus or minus if you introduce an even root. This was an odd root. Power over root, you introduced a third root. No plus or minus needed. But I am going to convert this problem to be the third root of 8 raised to the 4th power. Move that over a little bit, see a little bit better. The third root of 8 to the 4th power. I can evaluate this piece by piece, but the third root of 8 is 2. And 2 to the 4th power is 16. Which, of course, we can break down piece by piece if need be. You can show the progression of steps. This right here is a perfect progression of steps that shows I don't have to exactly show the -7 and show the dividing by 2. You can if you want to. But it's understood that those are the proper steps of progression. Now, you must always check for extraneous solutions. And all that means is that you take that number and you plug it back into the original problem and see if it gives you a correct statement, a true statement. So I'm going to take that 16 and I'm going to shove it back into the original x right here. And now, in order to, listen carefully, in order to evaluate in the right order, I have to do PEMDAS. 16 to the 3/4 power. Well, the 4th root of 16 is 2. Third power is 8. 8 times 2 is 16 again. Plus 7 is 23. It works. There's a thumb. It's a thumbs up. Since it works, I'm done. The only time I have to label my answer as extraneous is if it gives me a false statement. And like I said, typically those false statements are like 1 equals -1 or 10 equals -10 or some junk like that, which we may see a little bit later on down the road today. Okay. Let's look at number 6. Get my little paper out here. Flip the worksheet back. For number 6, this is the worksheet that we're working off of. Number 6 is 2x to the 5/3 power equals -64. And that's what it looks like. 2x to the 5/3 power equals -64. Okay. I think SADMAP. There's no addition, subtraction. More importantly, there's no parentheses. Okay. There's just multiplication and an exponent. Well, multiplication, division, here we go. Got to divide by 2. Okay. Oh, I didn't even divide by 2. What am I doing? I didn't even do it correctly. There we go. Sad days for me. I said divide by 2, and I didn't actually do it. Now, we got to do it with the exponent. I could raise both sides to the reciprocal exponent. I raise both sides to the reciprocal exponent. This is what it would look like. Nice. Cancels out on the left. I put a root on the problem, but the root that I put on the problem was a 5th root. And since it was a 5th root, that is an odd root, I do not need a plus or minus. It is very important that you mentally check every single time, okay, did I introduce a root? Yes, I did. Ooh, it was an odd root, so I don't need a plus or minus. It's only when you introduce an even root. So, this is really x equals the 5th root of negative 32, which I'm going to remind you how to calculate that in a moment, raised to the 3rd power. Now, the thing is, I am not expecting you. I am not expecting you to know what the 5th root of negative 32 is off the top of your head. I am not expecting that whatsoever. You can use the calculator to get it done, and I'm going to remind you how to do that in the calculator in a few moments. But you have to show me a progression of work. This is the progression of work that I need to see. Let's take a look at the calculator. Just reminding you, because I've shown you in the past how to do this, but I just want to show you again as a reminder. Let's see, get that back. There we go. Nope. There we go. You want to get the 5th root of negative 32? On your calculators, math, go down to x root, which is the 5th option under math, and you can type in the 5th root of negative 32. You have to have the negative sign in there, not the minus sign, but the negative sign. And the 5th root of negative 32 is negative 2, because negative 2 times negative 2 times negative 2 times negative 2 times negative 2. I'm going to get rid of that last negative sign there. There we go. Gives you negative 32. There are 5 negatives being multiplied together, so it stays a negative number. Cool. So that should give me negative 2 to the 3rd power, which shouldn't take that long to figure out, is negative 8. Always double check your answer. Always check to see if it works or if it's extraneous. So I'm going to take that negative 8. I'm going to shove it back into the original. Power over root. It's going to be negative 8. I got to take a 3rd root. Again, you could use the calculator, but the 3rd root of negative 8 is negative 2. Negative 2 to the 5th power, calculator, is negative 32. Negative 32 times 2 is negative 64. It works. Excelente. Again, like I said, if at any point you're like, I think I can handle those other problems. Just to remind you, I'll put this back up here. You can do those problems with me, which I'm going to continue working through, or you can try those problems on your own, and I will review a few of them before we leave here today when I call y'all back. So I'll leave that up there just for another moment. For those people who want to copy that stuff down, you could try the rest with me on the left, or you can try the problems on the right on your own. Knock them out, and then we'll review a few to see if you did them right. Okay, I'm going to try number 11 now. Oh, my microphone and my heart. There we go. Number 11. Let's see. Now, this one is interesting for the simple fact that you need to recognize the type of notation that is there. Oh, excuse me. I had to sneeze. I have to do it again. Oh, goodness gracious. Good thing I sneezed away from the microphone. Otherwise, you guys would all be sick right now. Sick of me. Oh, anyway. There's number 11. Now, notice that 3, notice that 3 is not a small 3. Notice that 3 is not in that crevice of the radical symbol. That is not a third root. That is not a third root. That is 3 times a square root. Recognize the type of root that you have in front of you. Also recognize that even though they're not in the original problem, you have to assume parentheses within that radical. Meaning you cannot touch that plus 6 until you get to the parenthesis step of SADMAP. So you're going to have to take off that 5, then the 3, then the square root, then the 6. So let me take off the 5. I take off the 5 by subtraction. I take off the 3 by division. I take off the square root by squaring both sides of the problem. Now notice again, once I get inside of that square root, the parentheses technically drop away because now I'm at the parenthesis step. Unless there were additional terms on the inside, but now I can just subtract 6. Let's check to see if we're right. 3 plus 6 is 9. Square root of 9 is 3. 3 times 3 is 9. Plus 5 is 14. It's a very logical progression from one step to the next. But obviously, they're going to get progressively more difficult. Let me look at number 16. Yeah, let's talk about number 16. Because after number 16, 21 and 22 are really the bigger problems that I want to get to. But let's talk about number 16. The 5th root of 3 minus x plus 4 equals 3. Please be very careful with this 3 minus x. I have a lot of people who end up screwing it up when they get to the end of the problem. Be careful. Yes, your first step is to subtract 4. Let's deal with that. If you subtract 4, you get negative 1. Raising it to the 5th power. Again, be careful when you're raising a number to the 5th power. You could use the calculator to get that thing done for you. But when you raise a negative to the 5th power, it stays negative because you have an odd number of negatives being multiplied together. Negative 1 times itself 5 times will just give you negative 1. It doesn't change anything. The biggest issue that people have with this particular problem is just keeping track of your negatives in an appropriate way. That is a positive 3 on the problem. And since it is a positive 3, you're going to want to subtract 3 from both sides. When you subtract 3 from both sides, you end up with this. Again, be careful. Biggest issue that people have is messing up one of the negatives. Divide both sides by -1. You get an answer of +4. Let's plug that sucker back in. 3 minus 4, -1. The fifth root of -1. Again, if you want to do the fifth root of -1, I can show you right here. Math, fifth root of -1, that's a 0. -1 is just -1 because -1 times itself 5 times. And then -1 plus 4 is 3. Oh, happy day. Let's see what number 21 gets us. I do have a bonus question to kind of show you guys after I finish these, but let's talk about number 21 first. When I mention a bonus question, you'll see what I mean when we get to it. A fourth root equals a fourth root. This is a golden problem. Because it's like, oh, a fourth root equals a fourth root? Okay. Can I just raise both sides to the fourth power? Why, yes, you can. You can indeed. And if you raise both sides to the fourth power, you're just left with 2x plus 1 equals x plus 6. And now it's just like an algebra 1 problem or a pre-algebra problem. The only reason we're allowed to do that is because there was a fourth root on both sides of the problem, on the outsides of the problem. By raising the left and the right side to the fourth power, it cancels out that fourth root, leaving you with the innards. So subtract x, subtract 1, x equals 5. Okay, that's weird. Let's check our answer. Take that 5 and plug it in here. Oh, you get the fourth root of 11? And over here you get, oh, the fourth root of 11. Oh, you get the fourth root of 11. What is the fourth root of 11? I don't know. I have no idea what the fourth root of 11 is. It's a decimal. The fourth root of 11 is somewhere between 1 and 2. I believe it's somewhere between 1 and 2. I think it's like 1 point, I want to say it's like 1.6. Let's find out. The fourth, come on, you. Come on, you. The fourth root, 11. I was close. It was 1.82 and change. But I don't need to know that. All I need to know is that, oh, it gives you the same answer on both sides. Why, yes, it does. Done and done. All right. Let's look at number 22. And then I have a bonus for you. Number 22 is going to be a bigger problem. Number 22 is the square root of x plus 2 equals x plus 2. There we go. So how does one handle this problem? First, since the square root is the outside layer on the left side, I think it's best that we just get rid of that by squaring both sides. If you square the left side, that square root cancels out, and you are left with x plus 2. But if you square the right side, all of a sudden, it's x plus 2 squared. Oh, that's a bit of an issue. So what do? Well, you're going to have to multiply out x plus 2 times x plus 2. Yeah, you're going to have to multiply that out, x plus 2 times x plus 2. So this is really going to be a little box that I'm going to multiply out, x plus 2, x plus 2, x times x times 2, x times 2, and a 4. So on the right side of the problem, it's not an x squared plus 4, it's an x squared plus 4x plus 4. That changes the complexity of the problem. And that's equal to x plus 2. You have to know when to multiply these things out correctly. It's a quadratic now, which brings us back to what we did in September, October. I got to get one side equal to 0. I'm going to subtract x. I'm going to subtract 2. And if I do that correctly, I end up with the following quadratic. X squared plus 3x plus 2. Nice. So let's see what happens. If I factored that correctly, again, going back to what we did in October, factoring, I taught you the Tucker method. Some people learned other methods that were not as effective as mine, my opinion. You could factor this into x plus 2, x plus 1. And with x plus 2, x plus 1, let me move this up a bit. Zoom in a bit on the bottom here. You get answers of -2 and -1. As a reminder, after you factored, you would take each term and set them equal to 0 and solve. Well, I get answers of -2 and -1. But do they work? Last class, we did a problem like this, and one of the answers ended up being extraneous. See what happens. Because extraneous answers could happen. And you have to check. So let's check them. Let's try the -2. Oh, can't see it. -2 plus 2 is 0. The square root of 0 was 0. Okay. -2 plus 2 is 0. Oh, you get 0 again. 0 equals 0 is a true statement. So x equals -2 works as a solution. Let's try the -1. -1 plus 2 is 1. The square root of 1 is 1. -1 plus 2 is 1. I got another true statement. I got another true statement. 1 equals 1. Is that possible? Yeah, it is possible. Both answers work. Both answers work. You got two solutions here. That's the way this problem rolls. Ah, it's wonderful. So wonderful. I love it so much. Okay. I want to show you one bonus problem, and then I'm going to go over a couple from the other list. So actually, I'm going to suggest for those of you that were working on the other problems, and I'm trying to get their attention now, those other students who were working on the other problems, hello out there. I am going to be going over a bonus question, and then I can either take a few of your questions or go over a few of the problems that you just did on your own. But I want to give you a bonus first, a bonus question first. Bonus! Check this junk out. The square root of 2x plus 3 equals the square root of 2x minus 1. There's a bonus question. Look what the heck happens here. Because this is amazing. First, notice that there's a square root on both sides. I can square both sides. And once I square both sides, I I get this. So now what you've been taught for years still applies. You're trying to get the variables to one side and the numbers to the other. So you decide to subtract 2x and subtract 3 from both sides of the problem. And as a result, what the heck? 0 equals -4? 0 equals -4. Move that over so you can see it a little bit better. 0 equals -4. Because look, the 2x's cancel here and here. And the 3 cancels here. 0 equals negative. What? What's the answer? Well, last class, I taught you that the answer that you're actually looking for is a point of intersection. But what if there is no point of intersection? And even if you consider extraneous solutions, what if there is no point of intersection? This answer is false. Thus, there is no solution. At no point do these two curves cross each other. They don't. They don't. Typically, you would only get an answer like this if all of your variables canceled out. If all of your variables canceled out, like we just did here, subtracting that 2x canceled out all of our variables. Oh no. Now, this actually goes back to something that you were taught in Algebra 1. In Algebra 1, you were taught that if you end up with a false statement like this, with systems of linear equations, if you ended up with a false statement like this, then the answer is no solution, because they would have been like systems of linear equations. They would have been parallel lines. But if you ended up with something like 0 equals 0 or 4 equals 4 or some junk like that, a true statement, then you would have actually had like an infinite number of solutions. Yes, that still technically applies. But with these problems, you're not going to get an infinite number of solutions. It's typically you'll either get a solution or there'll be no solution. That's what we got. Okay. Now, for those of you that are working on the other 6 problems, because I do see various people have decided to exit the stream, despite the fact that I told them not to. Like, hey guys, I mean, we do have assessments coming up next week. Oh, I'm just going to skip the rest of class. Okay, that's fine. Let's see what happens with your grade. But for those of you that were working on the other 6 problems, I will gladly take your questions if you have them. And while you're thinking of those questions to type into the chat, I would like to actually do 1 or 2 of the questions that you guys were assigned. So, first question I want to hit is actually number 4. So let's start with number 4. These were the questions that I said, hey, do these on your own if you think you can handle them. And now I'd like to hit at least 1 or 2 of them. And then again, if you have any questions, throw those questions into the chat. I can see it right now in front of me. I can even see the number of people that are in the live chat. It's great. Boom. This is number 4. Double check that. Boop. Boop. Yep. Just double checking. So now, according to SADMAP, I deal with addition, subtraction, multiplication, division, exponents, and then parentheses last. I see parentheses, meaning that -1, I'm actually not going to touch until last. I'm not going to touch that -1 until last. I can't touch it now. Let's see what happens. The outside layer is the exponent. So I'm going to have to raise both sides to the power of the reciprocal. Cool. Cancels out the exponent on the left. And now I'm going to have to evaluate what happens on the right. But hold up. Hold up. What the heck? What the hey? What the who? I introduced a root to the problem. And not just any root. I introduced an even root to the problem. Right here. Power over root. I introduced a square root to the problem. All snap. That must mean I need a plus or minus. Yeah, you do. Put it in front of the 4 like that. Let's see how we can evaluate this sucker. So what I'm going to do, after putting in the plus or minus right there, it would be plus or minus the square root of 4 to the 3rd power. Because I'm going to have to evaluate that sucker. That plus or minus is just going to sit out front temporarily. It's going to sit out front temporarily. Square root of 4 is 2. 2 cubed is 8. X minus 1 equals plus or minus 8. Now, this is where it gets a little dicey. Pay very close attention to the next step. Yes, the next thing I want to do now that I'm inside the parentheses is add 1. However, you have to recognize that that is a positive 8 and a negative 8. It's 2 different numbers, positive 8 and negative 8. And you cannot just say the answer is plus or minus 9. You can't do that. So instead, watch what I'm about to do. Yes, I am to add the 1. I have to add 1 to both sides. So that's why there's a positive 1 sitting on the right side of the problem. But it is 1 plus or minus 8. So 1 plus 8 will get you a 9. And 1 minus 8 will get you a negative 7. I'll check them in a moment, but I'm going to tell you right now, they both work. They both work. The answer is 9 and negative 7, not 9 and negative 9. Because you have to evaluate 1 plus 8 and 1 minus 8. If I plug in that 9 into the original problem right here, 9 minus 1 is 8. The cubed root of 8 is 2. 2 squared is 4. It works. Let's try the negative 7. Negative 7 minus 1 is negative 8. The cube root of negative 8 is negative 2. Negative 2 squared is positive 4. They both work. I'm going to circle you. They both work. Good for them. Move that over a tiny bit. Let's see what else we got. Again, if you do have those questions, throw them into the chat. I think I'm only going to do, like I said, I wasn't going to go over every single one of the questions that you were doing on your own, but I wanted to go over a few of them. Let me see what else I want to do. Number 7, number 12, number 15, number 20, number 25. Let's jump to number 25. I feel like I want to jump to number 25 first. And then we'll probably wrap it up unless you have any additional questions. But let's talk about number 25. There we go. Boom. There's number 25 right there. That's a screw up right there. Okay. It's really cool when I do that. Check this out. I'm going to mark her really fast and then watch this. It'll be really cool. It looks like my pen is not moving that much, but it's like shading in a bunch of stuff. It's a really cool camera effect. Anyway, I digress. I got to square both sides. All right, let's square both sides. Let's see what happens when we square both sides. 3x plus 13 equals parentheses x plus 5 squared. We squared both sides. It's like we moved something from the left to the right. It got rid of the square root on the left, and it squared everything on the right. But in order to square everything on the right, you're going to have to multiply out x plus 5 times x plus 5. Let me save a little time and show you what that would look like. It really should be x squared plus 10x plus 25. You could create a 2x2 box in order to get that correct, or FOIL it out if you wanted to. Then I am going to subtract 3x from both sides, and I am going to subtract 13 from both sides, leaving me with 0 equals x squared plus 7x plus 12. Which again brings us back to October, where we just had to factor the sucker. I'm going to factor them like this, because 3 times 4 will get you 12, and 3 plus 4 will get you positive 7. Giving you an answer of -3 and -4. But, of course, I have to check for extraneous solutions. And extraneous solutions will show up if when you plug it in, it doesn't work. Let's see. Let's try the -3. If I plug that -3 in here, I get -9 plus 13, which is 4. I get the square root of 4, which is 2. I plug in the -3 over here. -3 plus 5 is 2. It works. Let's try the -4. -4 times 3 is -12. -12 plus 13 is 1. Square root of 1 is 1. All right. -4 plus 5 is 1. Yeah. It works. They both work. They both work. They won't always both work. Sometimes you may be faced with a situation where one of them doesn't work. Sometimes you might be faced with a situation where both of them don't work. And if that is the case, as long as you haven't made a mistake, you are to assume that they are extraneous and you are to label them as such. Okay. Now, as I've said, next week, I do plan on having a couple of assessments. I do plan on throwing a minor assessment at you in regards to solving these radical equations. That's number one. Number two, I do plan on having a major assessment in regards to the chapter as a whole. My goal for Wednesday My goal for Wednesday, because again, you have no school Monday. My goal for Wednesday is to review the chapter as a whole. And then we'll see what happens on Friday, because the assessment, of course, will be on the computer. But we'll get that thing done. Again, if you have any questions, make sure you are emailing me. If you have not left a comment in the chat, please make sure that you do so. I appreciate you guys hanging out with me on a Friday. We only got 1 week of this quarantine down. 1 more to go. Goodness gracious. Anyway, I'm going to let you guys go. I'm going to dismiss you. You all have a wonderful weekend. 3-day weekend. You got Monday off. And I will see you next time. Goodbye, goodbye. Take your stuff with you. Bye-bye. Get out. Bye-bye, bye-bye. Crab wave. Crab wave. Crab wave. Okay, bye.